Morning students, I welcome you all to this online enrichment class of standard 12, and today we are going to solve some of the JEE main questions and solution on limits. Before starting, I would like to advise that you learn all these formula of limits. There are 6 to 7 formula which we have already discussed in the previous topic and in the class also. So you go through them and then proceed for these questions, right? So now let us begin. Our first question of today, okay, this is limit n tends to infinity 1 square plus 2 square plus up to n square whole divided by n cube, right? So whenever limit tends to infinity is there, first you simplify this one, limit n tends to infinity. This has a formula 1 square plus 2 square plus 3 square up to n square. The formula is n whole into n plus 1 whole into 2n plus 1 whole divided by 6, and already there was n cube. Now if I cancel here n and here cube will be cancelled and only will be left things will be n square. What I will do, I will redistribute this. 1 by 6 I have taken common. This will be limit n tends to infinity. Then I will redistribute it like this, n plus 1 divided by n, then another n will be 2n plus 1 divided by n, right? So look at this. Let me save this content. Here if I have 1 by 6 limit n tends to infinity, n plus 1 divided by n multiplied by 2n plus 1 whole divided by n. So let me do this next step for this, right? Now for next step I will be writing it as 1 by 6 limit n tends to infinity. This was n plus 1 divided by n. So what I will do is I will redistribute it. This is 1 plus 1 by n multiplied by this one is 2n plus 1 divided by n. Now if I divide 2n by n plus 1 by n, so I will write it once again, right? So it will be 2n by n, it was 2, and again it is 1 by n. Now when n tends to infinity, you can see 1 by n tends to 0. That is, if n tends to infinity, that implies 1 by n will tends to 0. So using this value at this limit, what I will do is, here this will be 1 by 6 limit n tends to infinity, so it will be 1 plus 0 this value, and this one is again 2 plus 0, 1 by n is 0. So it is 1/6 of 1 multiplied by 2, and the answer will be 1 by 3. So I would like to request that you backward this video for some time and see the solution from the beginning once again. Okay, let's proceed for the next question then. Let me save this content. Now in the next question also, that one is an easy question. Please see, that is question number 2 for today. Limit x tends to 0. This is sine 2x multiplied by sine 1 by x, right? There are 4 choices here, and given that x is not equal to 0, our first choice is 1, second choice is 0, and third choice is -1, and fourth choice is doesn't exist, right? So let us see what should be the correct solution. So let me solve it from the beginning. Now look at this. Here sine 1 by x, sine 2x, and when x will tend to 0, simply you write the answer. For this x tends to 0, so it will be simply limit x tends to 0. If I put the value, it will be sine 0. Although this one is undefined, you keep it as it is, right? This is 1 divided by x. So sine 0 value becomes 0, 0 into anything, that is sine 1 by x, which is infinity. Sine infinity will have a value, and the value will be ranging from minus infinity to minus 1 to plus 1. I repeat, sine infinity value, sine of any angle, the value will yield you either from minus 1 or the highest value will be plus 1. So, there is a real value for this. So, if this is real value, then 0 into any real value will become 0. So, this one will be the answer to this question, right. So, the answer will be 0. Next, let me save this content. Next, let us proceed to the next question, right. The question is, you see, question is, this type of questions are very important. This is question number 3 for today. Limit x tends to 3, this is x minus 3 divided by modulus of x minus 3, right. Now, the options are here, first option is 1, second option is minus 1, and third option is your 0, and this is doesn't exist. Okay, let us test it, right. Now, if I put limit x tends to 0, x minus 3 by modulus of x minus 3, for this question let x minus 3 it is equal to t, suppose. Now, when x tends to 3, then I will have t tends to 0. So, my question is converted to now limit, in place of x tends to 3, I will write t tends to 0, and this is t divided by modulus of t. Now, here I have to see two things. Modulus gives us two values. Mod t will give you mod t, it is either plus t or minus t, and plus t it will be when x is more than 0, and minus t when x will be less than 0. Okay. So, using this, that means this is a confusing thing. So, for this confusion, what I will do, I will find both LHL and RHL, that is left hand limit and right hand limit, right. Let me save this board. Now, if I save it, then this is limit t tends to 0, this is t divided by mod t. If you remember regarding LHL, LHL is nothing but limit t tends to 0 minus, this is t divided by mod t, and as you know, this is limit, you remove now 0 and plus or minus 0, then t, when t tends to 0 minus, that means negative value of t will get, and mod t will give you minus t, and it will be giving you minus 1. Then RHL will be nothing but limit t tends to 0 plus, and this is t divided by mod t, that is limit t tends to 0, t divided by mod t, at 0 plus mod t will give you plus t. So, t by t it will be 1. So, clearly it shows that LHL is not equal to RHL. In this condition, what we say, the limit exists or doesn't exist, that is limit doesn't exist. So, the correct answer will be limit doesn't exist. I think this concept is clear to you. So, here let me save this one. This question, the limit will not exist. Next question, let me proceed. This is your question number 4 for today. Looking very simple, limit x tends to 1, this is sin pi x divided by x minus 1, right. So, how to solve this question, sin pi x divided by, now if I put here x tends to 1, so that means it will be sin pi divided by 0, sin pi value is also 0, so it is in 0 by 0 form, right. So, for 0 by 0 form, no need to write in details, just you write this is in 0 by 0 form. So, for 0 by 0 form, I have suggested you to apply L'Hospital rule. So, applying L'Hospital rule, okay, let us see. If I apply L'Hospital rule, this will be limit x tends to 1, this will be converted into derivative of sin pi x divided by derivative of x minus 1. So, it will be nothing but limit x tends to 1, derivative of sin pi x will be cos pi x, pi into cos pi x divided by 1. So, if I put the value of 1 here, so the answer will be pi into cos pi, and pi into cos pi, the value will be pi into cos pi value is actually minus 1. So, the final answer it will be minus pi. So, this one is the final answer, and here you will be using a rule called L'Hospital rule, which is very essential and useful in finding the limits of certain functions, right. So, let us save this one. Now, let us proceed to the next question. Our next question is, this is question number 5 for today. This is limit h tends to 0, 1 divided by h into cube root of 8 plus h minus 1 divided by 2h, right. So, limit this one is h. So, h tends to 0. Now, let us think what to do in this case. I have 1 by h into cube root of 8 plus h, then this is minus 1 by 2h, right. So, what I will do is take the LCM. If I take the LCM, what I will get here, this one will be 2h into cube root of 8 plus h, then here h cube and 8 plus h is already present, so only 2 will come, and here minus what will go, this one will be, look at this, minus this one will be 2h is there, so it will be twice 2h will go, and this is cube root of 8 plus h. Now, you remember students, whenever you have such situations in algebra, what you will do, you will try to rationalize. Now, remember this one is a cubic rationalization, not a square root rationalization. So, for any cubic rationalization on our part, you have to do a bit of trick, right. So, what you will do, this is a cube root of 8 plus h, and this is also 2. So, 2 can be written as cube root of 8. I repeat. So, limit h tends to 0, I will be writing as cube root of 8 minus cube root of 8 plus h divided by twice h into cube root of 8 plus h. Okay. So, let me write the same thing once again. So, it will be cube root of 8 minus cube root of 8 plus h divided by 2h cube into cube root of 8 plus h. Let me save this page, right, and let us write this once again. Limit h tends to 0, this was our cube root of 8 minus cube root of 8 plus h divided by 2h cube into cube root of 8 plus h. So, what I will do, I will be multiplying certain thing here, watch carefully, this one is very tricky. What I will multiply is, this one is cube root of 8 whole square, then plus cube root of 8 into cube root of 8 plus h, then plus cube root of 8 plus h whole square, and the same thing I will multiply in the denominator. This is, you give a very big bracket for this. So, same thing you multiply it in the denominator also. This is cube root of 8 its whole square plus cube root of 8 multiplied by cube root of 8 plus h plus cube root of 8 plus h its whole square, right, give a big bracket. Now, see the numerator. This is, suppose first cube root of 8 I will take as a, and cube root of b 8 plus h I will take it as b. So, this is a minus b into a square plus ab plus b square. So, this one limit h tends to 0, a minus b whole into, look at the numerator gives a square plus ab plus b square. So, it will be cube root of 8 whole cube minus cube root of 8 plus h its whole cube, right, divided by, this one will be 2h cube into cube root of 8 plus h, right. Now, let me put the value in the denominator of h equals to 0. If I put h equals to 0, your first term is cube root of 8, that is 2, and its square is taken. Then again cube root of 8, it will be 2 multiplied by cube root of 8, which is also 2, plus again cube root of 8 plus h. If I put h 0, this will be cube root of 8, which is 2, and its square will be taken, right. So, look at this, limit h tends to 0, cube root of 8 it is, and cube is taken. So, 8 minus 8, this one is minus 8, and again this one will be cube root and cube will get cancelled. So, minus 8 minus h, and what will be left, this one will be 2h cube multiplied by under root of 8, cube root of 8 it is again 2, multiplied by 2 square is 4 plus 4 plus 4, 4 plus 4 plus 4 will give you 12. So, I repeat, here you can see 8 and 8 will get cancelled, and one h will also get cancelled. Is that clear? So, at last let me save this page. So, what I will have at last is limit h tends to 0, 8 and 8 was getting cancelled, divided by this one. Let me show it to you. Here it is. So, minus 8 divided by 12 into 2, it is 24 multiplied by 2, which is 48. So, what I will have is divided by h cube multiplied by 48. So, 1 by 48 is taken outside, limit h tends to 0. So, h also getting cancelled, minus 1 by 48, 1 by h square. So, minus 1 by 48 multiplied by infinity, which is infinity. So, the answer will be infinity here, right. So, like this you have to solve the questions. Now, when I have this question, you just practice it by looking at the backward steps when I have just rationalized a cubic function. You can see very easily that we have done it very easily. Actually, in the original question, this was not h cube, this was h only, right. So, here if I have this one is h, in the original question what it was h only, it is a rectified question. So, if I make it h, here it will be 1 will be left, h will get cancelled. So, here actually it will be 1 by 1 and the answer will be 1 by 48. So, let me show it once again, that will be limit h tends to 0 minus h divided by h multiplied by 48, h is getting cancelled, and I am getting the answer to be minus 1 divided by 48. This was the original question. I have written by mistake this one as h cube, that is why we are getting upside answers. So, it was actually h. Now, let me save this page. Let us proceed further to the last question of today, right. Now, the question is limit x tends to 0 sin x degree divided by x. So I know a formula, limit x tends to 0, sin x divided by x, it is equal to 1. Now remember, whenever you apply this formula, your x should be in radians, but here the value of x is given in degrees, right? So for doing the same thing, what I will do, first I will convert degree into radians, right? So I know a formula that pi radian equals to 180 degrees. Okay, so 180 degrees, it is equal to pi radian. So 1 degree will be pi by 180 radians, and x degrees, it will be pi x multiplied by 180 radians. So that is equal to limit x tends to 0, sin, this one will be pi x divided by 180, and I need the same thing in the denominator also to write our formula. So it will be pi x divided by 180, and to compensate, what I multiply is 180 divided by pi. Here everything is getting compensated, right? So look at this, the value of this, this and this, it will be 1, and what will be left, 1 by 180 by pi, so it will be nothing but pi by 180. So your final answer will be pi divided by 180. Is that clear? So this is all for today. Let me save this page. You just see it carefully, all the solutions, and I am giving you some of the homework, right? So you note this homework and try to solve it. Is that clear? So I will be giving you 3 questions. Number 1 is limit x tends to infinity under root of x square minus 1 divided by 2x plus 1. My number 2 question is your limit x tends to infinity x factorial divided by x plus 1 factorial minus x factorial. Now number 3 is here limit x tends to pi by 2 sec x minus tan x. So these 3 questions are your homework. Try to solve it, and if any question is there, I will be discussing it in the next query, and you place the query also, I will be solving it in the next class. Okay, that's all for today. Thank you very much.